In this video, I demonstrate how to set up and configure a cross-platform development environment for the cross-compilation of C and C++ programs for embedded Linux devices. I've made this video twice before, but they tend to go out of date. The last video went out of date quickly when there were severe server problems with Debian Wheezy. This video is focused on Debian Jessie, which was officially released on the 25th of April 2015. I'm hoping that the instructions in this video remain valid for quite some time. The good news is that the Debian team have done a great job and the process is now easier than it was ever before. This environment will work for any embedded Linux device, but the BeagleBone Black is used in this case. The video covers several topics, such as installing a toolchain for cross-compilation, installing the Eclipse C++ development tools, which is known as CDT, using the Remote System Explorer plugin for Eclipse, automatically deploying an executable to the remote platform on compilation, and cross-platform debugging within the Eclipse environment. This video was created to support the materials in Chapter 7 of my book, Exploring BeagleBone. The video is self-contained and you don't need the book to follow this video. However, I have not covered some additional materials such as GitHub integration, change routes, Doxygen integration. For the support materials and all of the source code for this book, please see exploringbeaglebone.com. For this installation, I'm using a Debian Jessie, which is Debian 8 image, and it's a brand new image. There's nothing installed except for the steps that are described in Chapter 3 at the bottom. All I've done is installed the, it's running inside an Oracle VirtualBox instance. So the only thing that I've done here is just set up the Linux editions within VirtualBox, and also I've installed CairoDoc at the bottom here, just to make it easier to access the terminal. So those instructions are described at exploringbeaglebone.com/chapter 3. So we can just open up a terminal, and just to confirm the image, we can use screen fetch. You can install screen fetch. It's just a package, apt-get screen fetch, and you can see it's Debian Jessie, and I'm using it inside a virtual box image, so it has a portion of my memory and my machine. So just make sure you've sudo installed for the following steps. So you can do that. I already have it installed, I think. Okay, you've got my password, apt sudo. Yeah, it's already there. And just make sure as well that under vi sudo that you've added in user privilege specifications. So molloyd all equals all, :all, all. Okay, that's fine. You can exit the root and Control L to clear the screen. Okay, so the first thing we need to do is update the sources list, and this is what we need in order to install the cross tools. So to do this, we go into cd/etc/apt sources.list.d. Tab will auto-complete the line. So in this directory, there's nothing there at the moment. We want to make a file. So I'm going to go sudo nano crosstools.list. So crosstools.list is the name of the file, and we're just going to edit that with nano. Okay, and the only entry that has to go in here is deb http://mdebian.org/tools/debian space Jessie space main. And that's it. Control X. Just to show the detail, and that's all we need at the moment. The next thing we need to do is install curl. So sudo apt-get install curl. So it's already installed. That came. I might have actually one thing I might have installed is the build essentials. So sudo apt-get install build essentials. I needed that for the guest editions. Oops, build essential. Okay, so that's up to date. So make sure that you've sudo apt-get install build essential before you continue any further. The next step is we have to download the Debian toolchain archive key. And to do this, it's a long line, it's all in one line. Curl http://mdebian mdebian.org/tools/debian/mdebian toolchain minus archive.key pipe sudo apt key add minus mdebian.org tools debian mdebian toolchain archive key. So just make sure you spell mdebian correctly. Okay, that worked perfectly, 100% okay. That's done there at the moment. So we can continue on from there. So I'm going to go back to my root directory. Okay, there's nothing there. So we need to now add an architecture. So for this example, I'm going to cross-develop to ARM hard float. So we can do that. We can say sudo dpkg --add -architecture architecture ARM HF. Okay, we can see at the moment the current architecture is ARM AMD 64. That's my current architecture on my current machine, and print the foreign architecture. Architectures, actually, we can have multiple. My only foreign architecture is ARM HF, so that's the what I'm planning to build. Okay, we can update sudo apt get update. Okay, and importantly, you'll see down at the bottom, it's pulling in my ARM HF packages. All going well. The next step is fairly straightforward and really important. Sudo apt get install cross-build minus essential. It's much easier to do this under Jesse than it is under, and it ever was on any other, if it works, than any other release like Wheezy. So sudo apt get install cross-build ESS ENTIAL ARM HF. 111 meg, yes, that's fine. And you can see there that it's planning to install a lot of different tools that are important. G++ 4.9 minus ARM minus Linux, GNU EABI HF, and all the other tools that we need as well for cross development. Okay, so you can go ahead with that. Okay, so that looks good. We can test it now. So we'll go into, I'm in my root directory. Oops, jumped out. So there's nothing here, it's a brand new image. So I'm just going to create a test C++ file just to test the application. So we can just go nano test.cpp --include iostream. Oops, that's kind of yellow. Using namespace std int main hello from an ARM. Okay. Okay, so just hello from an ARM HF architecture endl. So we can quit out, Control X, save it, yes, more test.cpp just to show that it shows up. And everything looks good. Hopefully there's no mistakes in that. I don't think so. So we can compile this now. We should be able to type ARM Linux GNU EAB HF G++ test.cpp -o test. So -o, my output file name is test. And that's it. You'll see there's my executable, and it shouldn't execute. /test. Cannot execute binary file, exec format error. And that's a good sign, because that means that we're building that for the ARM hard float instruction set. So I'm currently on an AMD 64-bit machine. Well, it's an Intel 64-bit machine. So it means that I shouldn't be able to execute it on this platform. So we could just transfer it to the BeagleBone to test it. So I'm going to SFTP it to my BeagleBone, which is SFTP, and it's malloyd at 192.168.7.2. Yes, I want to continue to connect. Okay, I'm connected. So I'm going to put my, what was it called again? Test. Put test. Okay, exit. And now I'm going to SSH over to my BeagleBone, so I can execute it on the BeagleBone. Malloyd, it's my username on the BeagleBone. 192.168.7.2 is the default Internet over USB IP address for the BeagleBone. So you can see I'm on the BeagleBone, malloyd at BeagleBone. The GitHub repository is there. And the file that I just put there this second is May 5th. The file, it's I can just execute it now. So let's just try it. /test. Hello from an ARM HF architecture. So that's exactly what we would expect. So at this point, I now have a working cross-compilation environment on my desktop machine. So my AMD 64-bit machine can cross-compile code that can execute directly on my ARM HF architecture, such as the BeagleBone. Okay, I'll just return back to my desktop machine. I'm back to my Debian Jessie desktop machine, and all I have here is my test CPP and my test executable. So I'm just going to look at two different things that are optional before you go on to the installation of Eclipse. One is the use of multi-architecture code, and this is a lovely feature of building cross-developing under Jessie, is that it has good support for multi-architecture installs. So for example, we can do this. We can say sudo apt get install, and let's say we install any driver, libicu dev. Now if I hit enter at this point, it would install libicu dev for my desktop machine, which is my AMD 64. But if I put :ARM HF at the end, you'll see that it's going to install the ARM HF version of my tools. So you can see it's going to install libicu dev ARM HF version 5.2. So I'm going to continue on with that. Okay. And you'll see that under Debian Jessie, this installs these packages under /user /lib /arm arm linux gnu eabi hf. If we go ls-l, let me just do ls. You can see my lib ICU IO and all the other packages for version 52. So that's my installation of those packages. The reason that that's very useful is because if there's a library, a third-party library that you need for your project, you can use that structure to install third-party libraries to make it easy to cross-compile for your ARM platform. One other thing we can do, which may be useful, it can be buggy at times, just cd:/, Control-L, to clear the screen, is to install QEMU, which is an emulation for ARM, so that we can emulate the ARM HF architecture. So we can do that. Sudo apt get install QEMU user static user emulation mode 82 meg. Yeah, that looks good. Control-L. So again, in my directory I have my test application, and if you remember just a moment ago, I executed this test application and it wouldn't work because of the fact that it was an ARM HF binary. If I actually type /test now, you'll see it works. And what's happening here is my QEMU user emulation mode is actually interpreting this code for ARMHF, the ARMHF architecture. So it's emulating it, and I'm getting my output now at this point. I think it's useful to have that, but it's not necessary for cross development. The next step is that I'm going to install Eclipse on my desktop machine. Just going to install Chromium very quickly. Eclipse.org. And I'm going to download it. Why isn't my button active? Okay. Eclipse IDE for Java developers? No. Java Enterprise developers? No. Eclipse for C++ developers. Linux 64-bit. It's picking up that I'm in Ireland, so it's downloading from there, so we can go along. Thank you for downloading. cd:/downloads. Downloads. Okay, it's my only file. tar -xvf or xvf Eclipse. Okay, and that's it. So you end up with the Eclipse folder. Now Eclipse runs directly within the folder, so I'm just going to move this Eclipse folder, Eclipse to /. Okay, cd Eclipse, and now it just means that I can execute it directly within that folder from now on. And I think that's a sensible way to use it. It's installed for this user account, so we can execute it. Okay, Eclipse Luna starting up. There's a few messages there, GTK messages, but they look okay. Home Lloyd workspace, that's okay, that'll do us fine for our home directory. So Eclipse Luna has started up on my machine. Okay, and it's set up for C++ development. There's a good guide at the start that gives you an overview and tutorials of how it works. And that looks good. So now that we have it running, we can create a new project, File, New, C++ project. And this is a lovely feature of Luna, is that there's a new cross GCC option up here. So I'm just going to call this project Test ARM, and I'm going to use the Hello World C++ project just because it's easy, and choose the cross GCC. Set the author. Next. We want to debug and release option. And this is where we set up the cross GCC command. And the compiler, the cross compiler, you remember, is ARM -Linux -GNU EABIHF. So we can just enter that here. ARM -Linux -GNU EABIHF minus. The minus is important. And that, if you remember correctly, is in the directory user/bin. Okay, and we can finish. And we can close this screen, and we're in our project. Okay, so everything looks good. I'm just going to change it slightly. Hello World ARM is the message here, so that it's going to print out Hello World ARM at the end of the when we execute it. At the moment, my project has its includes and its source. You can see that the includes the ARM Linux GNU EABIHF directory by default, and we should be able to save this and build project, and it looks like it worked. Doesn't seem to be any issues, no problems. Build took 392 milliseconds, that's a good sign. Everything looks like it's in order. And you can see here that we have a binary, and this is very important. The test ARM LE should be present at the end of this. This means that we have built a binary and the instruction set is ARM LE. Okay. We should be able to even execute it here. Now the only reason I'm allowed to execute this here is because I installed QEMU earlier in this video. If you don't install QEMU, you'll get an error at this point here. The properties are still set, so C++ build environment is still set. We can set our environment variables and so on. It's automatically detected because of the fact that we have this tool chain installed. So under C++, we can still set the paths and library directories, library paths and so on, but they are automatically detected because of the way that we've set this project up. However, just be aware that this is where if you have to add in a third-party library or your own source code in a different directory, do it through your project properties. The next thing I'm going to do is I'm going to install the Remote System Explorer. So for this, we're going to install new software. Set this to Luna. It was quite slow to appear. Under General Purpose Tools, we can go down and somewhere here we should have Remote System Explorer User Actions. So I'm going to select that and install this. Next. Okay. Framework for contributing user-defined actions and compile commands. I accept the license agreement, which I've read, and press finish. Restart. Yes, I would like to restart. Okay, so not too much has changed, but if I go in here now, Window, Show View, Other, somewhere, Remote System, I think, yeah, Remote System, and it appears down here. Now I prefer it up here, so I'm going to move it up here. And at this point, this is how we're going to connect to the BeagleBone. So the whole purpose of the Remote System Explorer is to be able to connect to the BeagleBone. The alternative is to FTP your application over to the BeagleBone every time, like I did earlier, and then execute it on the BeagleBone. But this will allow us to integrate everything together. So the next thing I'm going to do is I'm going to add a connection to the BeagleBone. So it's the Linux system. Next, the host name is 192.168.7.2. That's the IP address of the BeagleBone on my network. The connection name is a name that we can give it to make it easy. And next, okay, we're going to SFTP. We're going to SSH the files. That'll do fine. Next, we're going to use processes shell Linux. That's fine. And for shells, we're going to use SSH shells. Okay, and terminal, SSH terminal. Hit finish. Okay, so that gives us a remote view of the BeagleBone. And the really good thing about this is we should be able to just build our executables and deploy them directly to the BeagleBone, which is going to be very useful. So you can see if we now connect to this, okay, now I just did this a second ago, but you should be prompted for your username and your password. But you can see that it's storing my username and password because I just did it a minute ago. So we go in, you can see that we can see the files that are in the directory. You can see the test program from just earlier and the GitHub repository. And you can see that we can do things like we can set up a terminal. We can just say launch terminal and it appears here. And you can see I'm now within Eclipse on my desktop machine, but I'm straight away inside my executing an SSH terminal directly within my BeagleBone. So these are lovely features as part of Eclipse for cross development, especially when we're working with a live embedded Linux platform. So that gives us our terminal. And we can just see that that was the same .test worked perfectly as before. And so I can close that. So we could take our executable. One way we could do this is we could transfer. If I take my test, I can delete this, for example. That's the one I built earlier. I could, for example, take my test arm binary, right click it and go copy and go to remote system into my home directory and go paste. And you'll see that it copied my test arm application in there. I just close the terminal. I'll open up a new terminal again. Launch terminal, ls-l, and you can see that my test arm binary is there. One problem is that if you copy and paste like this, it will not capture the executable attribute. So it means we have to chmod a+x test arm so that it now has the executable flag set. Now we should be able to go test arm. And it says hello world arm, the same as our code example above. So you can see that this is one way that we could build and deploy our applications. It's easier than SFTPing and SSHing in. Well, I'm still SSHing in, but it's an easier way to deploy the application from within the Eclipse environment. But we can improve this further. So one way we can make this even easier for ourselves is to make it so that our desktop machine has full access to the BeagleBone directly without the need for a password. And to do this, and Control L to clear the screen, I'm going to use SSH minus keygen to generate a public-private RSA key pair. Just going to leave this blank. Empty again. So that's my empty random passphrase. And I'm going to do SSH minus copy this ID to malloyd at 192.168.7.2. Okay, I'm copying this file in to install the key. I've entered my password now so that I've authenticated myself on the BeagleBone, and I'm now back on my desktop machine. The interesting thing is if I now SSH into my BeagleBone, SSH malloyd at 192.168.7.2, you'll notice that I didn't have to enter a password. And that's a useful feature because that allows us to automatically deploy our executable from within the Eclipse environment directly onto the BeagleBone. And we can do that as a post-build step. So just to make it very clear, I'm on the BeagleBone now. So I'm on Linux 3.8.13 Bone 70. So we're going to set up this post-build step. So in my project, if you remember, my binary is called test arm. So we want to copy that automatically to our remote file system. I'm just going to delete that here just to make it clear that we're doing this automatically now. So delete the object on the remote system. You can see test arm is now gone. So back into my directory. So we can go to project, properties, C++ build, settings, build steps, and I'm going to put in a post build step. So this happens after our application is built. So I'm going to use the scp command, which is covered in chapter 11 of the book. Test arm, which is the name of the executable in our build directory, to malloyd at 192.168.7.2 and then :/home is the path, malloyd, and we're going to copy it directly to bbb test, just to demonstrate that I'm renaming the application to test arm. Okay, so press OK. That seems to be okay. You'll notice there's still nothing there. So if I build project or hit the play button and check the console, and you can see here that there's make -no print directory post build scp command is being called there at the end, and everything looks good. You'll find any errors there at that point, for example if your the previous step didn't work correctly. So at this point we can go into our remote system, and you can click here, make sure you refresh or hit F5, and you'll see that we have our bbb test program there. So at this point we can go ls-l, and we've got our test arm that was there before. That was the old one. Delete that, and /bbb test, and you can see hello world arm, just to show how well this works. So again, when I execute this, it's hello world arm. I'm just going to update this. So let's imagine we're making a change to our project. Hello world BeagleBone. Okay, so all we have to do is as here, project, build project. I think that was fine. /pb test. Oh, it didn't work. What happened there? Oh, I never saved the file. Okay, save the file. Project, build project. Now try it. Hello world Beaglebone. Okay, and that's working very well. So that means now that we can very quickly and very easily remote deploy our application, build our application, make a change, and remote deploy it to the Beaglebone with one click. And I think that's very useful. The next step is that I'm going to install remote debugging on the Beaglebone. This is an advanced feature that allows us to deploy an application to the Beaglebone and yet run our debugger and see our visual output from within Eclipse on our desktop environment, which is very useful. The first thing we need to do though is on our Beaglebone we need to install GDB server. So sudo apt get install GDB server. Probably from my password. Okay, that's handy. It's already installed by default. That's the default Debian distribution. GDB server is installed by default. The next thing I need to do is I need to open up a terminal to my local machine. So if I come down here, I can open up a terminal. So I'm on this is my desktop machine, and I just want to install multi-architecture debugging. So sudo apt get install gdb minus multi arc. Okay, so that's done. We just have to do one more thing. I have to go into my workspace directory. Workspace, yeah. And I just have to create a file in here. And the file is a hidden file, so it has a dot in front of it. So we can edit this nano dot, and it's called gdb init. So nano dot space dot gdb init. And this just needs one line, and it's very simple. Set architecture ARM, and that's it. All we're doing there is telling the remote architecture, well, the multi-architecture debugger that we're using an ARM remote machine. Save that. Control X, Y to save, and just check that it's fully in place, and it is. Okay, so we can go back to Eclipse now. I'll just leave that there to the side. We can go back to Eclipse, and the next thing is we want to just set up a debug configuration. So under Run, go down to Debug Configurations, and here you'll see there's a couple of different entries here. I'm going to make this a little bit bigger. Now you'll see under these categories we have C++, C++ application, attach application, postmortem debugger, and remote application. We're interested in remote application. I'm just going to delete this here just for clarity. Delete the launch configuration, yes, and I'm going to add a new one in here. New. Okay, so all the settings here are taking place under remote application. Okay, so this connection to Beaglebone, that's okay so far. I'll come back to that. Under debugger, we want to set this. You see that it's, I don't know if it's picked it up or if it's just found it. We can right click, show hidden files in our workspace directory. And I'm pretty sure it found it. Okay, that's fine. And we just need to change this to /user/bin/gdb multi-arc. Okay. Other options, well, we can set the GDB server. It's set for 2, 3, 4, 5. We can just set that for 1, 2, 3, 4, 5, just to be consistent with what was in the book. We also have to set the path, the remote path for the application. So we're going to connection to. So you see here under remote absolute file path for C++ application, you can see that it's actually on our local machine. So we need to change that to be the remote machine. So we can browse my home and we can deploy it to here. Okay, so at this point we should be able to debug. Let's try see what happens. Okay. Here's a debug perspective. That's good, 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 and good. So yes, perspective now. Okay, so everything looks good. There's a breakpoint set by default at the start of main, which is what we want. Everything looks good so far. Okay, we can just resume this and run it to completion. I'm just going to change this now so that we return back to our C++. I'm just going to create a very simple test. Int x equals 5, x plus plus, and that gives us a variable that we can set a watch on. Okay. So the variable present, project, run, debug as. Just see why that's happening. I don't know why it's running there. So we'll have to execute it from here. Test arm debug, remote application. Source to save. Okay, should have saved that. Debug perspective, yes it is. Switch to debug perspective. So you can see here it automatically picked up my variable x as being initially equal to 0. We can step over that line there. You see that x now has the value of 5, which is what we'd expect after completing line 13 here. X++ should increment this to 6. And the real value in this is that it allows us to build, and indeed it does, x has become 6. The real value in this is we can connect hardware to the BeagleBone or to your embedded Linux platform at this point and trigger LEDs or drive motors and see exactly the physical impact or read sensors. So you can read sensor values from sensors and write values to change motors and so on. And it allows you to debug your application live. And that's a very valuable feature in embedded Linux development, because you are attaching your embedded Linux platform to external hardware. Finally, we can step over and it should print out our message. Hello world BeagleBone appears on the BeagleBone side, and continue to step through. It should return 0 and quit the application, and that's the end of our application. So we're finished. We can view disassembly, get an indication of the of where we are and what the instructions are and so on. But that's essentially as the project has been built. One problem I've seen arise is that you need to specify the libraries. It seems to be perfect here at the moment. Hit stop to finish the whole thing. Project, run configurations. Just one last thing that you might need to do: debug configurations, debugger, shared libraries. You may have to specify the shared libraries here. So ARM, Linux, GNU, EAB, IHF. So that just means that we have our shared library set up for our project. Apply the changes, and we can just set up remote debug, just in case there is an issue with your configuration. You may have to do this, and you can see it's working exactly the same. There's no issue. We can step over again, and you'll see our variable set as 5, x++. You see it becomes 6, and we can just run to completion. So that's it. That's a fully working installation. We've got remote deployment of our application. We have remote debug. We can connect it to hardware and debug it right from our desktop machine, which is quite powerful and gives us a good visual control over the code that we're building on the BeagleBone. So hopefully that's helped you configure and set up your environment. Thank you.